Our next topic on our agenda is lake resiliency. And this is a focus area we started addressing over a year ago in our quest to bring you what I would call content-rich topical information that will help you strengthen your lake and river associations, your COLAs and your LORAs. We've had throughout this journey the great privilege of being coached by Rebecca Carlson, who is a very experienced local professional who wears several hats. She's the founder of Resilience Resources, the consulting business she runs. She's also the administrator and district engineer for the Clearwater River watershed. Rebecca, as we have done in each of the prior sessions on lake resiliency, will set the stage for today's presentations. This one, as we've mentioned, on the use of drones for surface water management. Rebecca, you're on. Can I turn the floor over to you?
Thank you, Joe. Absolutely. Okay. Thank you, everyone. I think you guys are all aware that we have some interesting speakers today joining us on remote sensing and some technology-driven improvements in evaluating lake resiliency. If you look at our pie chart that we had up just a second ago, you'll see we had climate, we had shoreline, we had a number AIS, we had a water quality. Technology and remote sensing intersects almost each portions of that pie. So I'm going to start out by just giving you a little bit of context, where we were 20 plus years ago and where we are now. When I started my career in water resources engineering, any given project would see me walking down the hall to our file and copy room, retrieving a set of paper topography maps with 10-foot contour resolutions, finding and then making copies, photocopies of the study area, and often taping pieces of paper together to cover the study area, hand drawing drainage areas, measuring with a planimeter, which is just kind of a way to measure areas on papers with defined scale. Air photos existed, of course, but we had to order them, purchase them, get approval for purchasing them. Then we had to overlay and intersect them with any sort of meaningful information like property ownership. And the resolution was not such that we could see what was happening on an individual shoreline, how water quality was changing with area. To give you some little additional frame of reference, a 2001 graduate thesis on using satellite remote sensing to measure and quantify water clarity was groundbreaking in 2001. So now in 2022, so in just the screen that I'm sharing is one of these old Minnesota USGS topography maps with the 10-foot contours. So like I said, we'd have to, they're giant pieces of paper and we'd have to kind of copy them and move them around. So I'm gonna share with you a couple others. Now I can go online for almost any county, DNR over the state, or USGS over the entire country. And I can navigate to a study area. I can have at my fingertips 2-foot contours, not 10-foot contours, 2-foot. I can have up to date within 1 to 2 years of historical air photos with high resolution. At Resilience Resources, we're only 4 years old. We have our own drone that we use to support our work. Being able to see what's going on in the landscape from the air has revolutionized the way we do our work to protect water and soil resources. So I will be sending out an email just with some of these resources for you guys to see, kind of click around in. It's MinTopo from the DNR. Each county has a wonderful databases and GIS online so that you guys can look through your landscapes, and USGS also. So today we have guest speakers, Reimink and Dennis Wiand, to tell us how they are pushing the envelope with technology, water, and natural resources. The title of their presentation is Innovative Applications in Drone Technology for Surface Water Management. Basically, one of the Ron's work, he comes to us from Freshwater Solutions. He was a high school teacher for biology 30 years in Southwest Michigan. So he retired, but continued and actually started an undergraduate research project. He started Freshwater Solutions to continue to do that research at his intersection of aquatic biology and teaching. So we also have Dennis Wiand, who comes to us from Zero Gravity Aerial. Dennis is a resident of Traverse City, and he's been working with lakes since the late 1990s. Dennis started as an ad photographer, got his pilot's license, and combined drone piloting with his background in photography. So I want to welcome Ron and Dennis, and also just sort of reiterate that this technology that they're using and then presenting to us, and the technology that has been developed at the federal, state, and local level, that funding for that technology supports us in our work in protecting water and natural resources. So Ron and Dennis, welcome.
Thank you. Good to be here.
Thank you. I think Dennis and I are going to run off my computer. So is it possible for me to share then the screen? Okay. And
that's working.
is that working? Okay. Let
Yep.
me go
Yeah,
to slideshow.
Just gotta get in the presentation mode. There you go.
Oh, are we good?
Looks good.
Okay. Well, first of all, thank you. It's great to be with other people who have a passion for preserving our beautiful surface waters. And Dennis and I obviously come from Michigan, northern Michigan, northwest Michigan, where we have a lot of beautiful lakes. And it's just good to share what we're doing with you. And hopefully you'll get some ideas on how maybe you can do better. I think when we work together and share information, the synergy there benefits everyone. So thank you for the opportunity. I believe we have about 40 minutes, and I'll keep an eye on the clock. Dennis and I actually presented something similar to this at the Michigan Inland Lakes Convention. It's a biennial convention, and it was held in October. And we presented something similar to this there. And I think that's where somebody caught wind of it and invited us to speak with you. So once again, thank you. Let me see. So this is just a brief outline, what we'd like to talk about here over the next half hour. A few little introductions. I'd like to introduce Dennis, especially, and then talk about drones. Why drones? What are we doing? What are some things that we're doing? And shoreline surveys, septic drain field analysis, elevation mapping, invasive species mapping, helping with what we're doing with Eurasian water milfoil, doing some plant surveys, some rapid response things. And since we were invited to do this, so 6 weeks ago, new things have come on the horizon, and we'll share those as well. So this is a video, Dennis flying a drone over trees on Glen Lake. And I met Dennis in 2017 because I was working on swimmer's itch research and control, and we were trying to find nests of common mergansers. And I got a call from Rob Karner, the lake biologist at Glen Lake, saying, hey, I got this guy flying drones, so maybe he could find the holes. The common mergansers nest in hollow trees. We're in a boat every morning in April, watching the birds fly around, ducking through the trees, trying to find their nests. We had the naive notion that if we got rid of the mergansers, we'd get rid of swimmer's itch back then. We've learned a lot since then, but at any rate, I said, yeah, I'd love to meet this guy, Dennis. And so in 2017, I met Dennis, and he's actually flying this drone and looking in an area where we saw birds going in and out of trees, looking for nesting sites. And he could see things with the drone that we couldn't see. And that looked like a great advantage. And that was our start. Since that time, Dennis and I have every year almost like doubled our involvement together. I enjoy working with Dennis. As Rebecca said, Dennis spent his life in commercial photography. Very competitive field. Dennis had always had to be on the top of his game in what he was doing with the equipment. And he continues that passion to always be at the top of his game with the newest and greatest, and which brings value to what we're doing, because I would put him up against anyone in his ability. I will warn you, though, that as we go through this presentation, Dennis will make things seem easier, and maybe I will too, but there may probably a little more complex on the background, that it takes to do this, but at least conceptually, you'll see what we're doing, sort of things that we can do. So let's go. What are the drone advantages? And I mean, obviously the number one thing is you get a different perspective, and you take a look at this. This is the same shoreline, and the one on the left is from our boat, and the one on the right is from the drone, and it just opens up the whole area, and we can see so much more. So that's one of the biggest. That is the biggest advantage. And when we take that and look at other advantages, here are some, and go ahead, Dennis, and we're going to kind of tag team on this. Dennis will interrupt me and I'll interrupt Dennis. I hope it's
so
enough.
as Rebecca was saying, and thinking about how she was going from office to office and looking for maps and so on, we create our own maps in a sense, but the big thing is the resolution. We can see things much clearer than you can from satellite or even from manned aircraft. And then it has the ability for multiple sensors that you can use, depending, you can buy prosumer drones. They're outfitted with sensors. Some are interchangeable, things like that. There's been great public interest in the last 3-4 years, tremendously. Whatever we gather, and especially with the RGB cameras, that footage is archivable. You can use it to quantify, do quantifiable analysis, as Ron will talk about further as we go. And it can be repeated. A lot of the flight is autonomous that we use, and we can fly it right exactly year after year. Things can be compared for change, for trends, things like that.
Mm-hmm. Yeah, so let's start out with shoreline surveys. We all, I think, recognize the value of how we treat our shorelines as riparians. And so we start with a KMZ file from local government that gives us all of the, this public knowledge, gives us all of the parcels on a given lake. And I just happen to click on mine, Ron and Linda Reimink. You click on that and it tells you who it is. But what we really use it for is we want to look at the parcels that are owned by private citizens, and we want to see how we're treating our shoreline. And so we look at different things with this footage. So these are all from the drone here. We can look over here, and let me get a pointer up here, and we can look at natural shoreline over here. We can look at green belt. So this is natural shoreline, this is green belt, and I'm sure you're familiar with all of that and the value of green belts to pull up nutrients. Non-green belts, where riparians just mow right to the edge of the water. Riprap here brought in stones and things that they're trying to prevent erosion. Seawalls, when we all sort of know the negative impact seawalls have. Lake water irrigation, we look for this with the drone as well, and of course we encourage that, because then they don't have to put any fertilizer on their lawns. If they want to have a lawn, they're bringing in nutrient water from the lake and putting it on. So we encourage that. We don't encourage beach sanding, bringing in artificial sand. We know that gets pushed into the water eventually with the erosion comes in, or the heavy storms. And also you take an area where it doesn't have the root systems to suck up nutrients from the water. So beach sanding, drain pipes, you can see it right here is a drain pipe. And of course, drain pipes are not advantageous either, because you're putting water from up there without a chance to pull out nutrients right into your surface water. Detectable algal growth is another thing we can see better with a drone. In this particular spot right here, we noticed, and for a stewardship committee or a lake biologist, if you have one of those, would go to these places and say, we need to check that out because there may be high nutrients coming in there. So we look for that. And then we take all of those things from every parcel and we go to Google Earth Pro and we put them in with a GPS coordinate at the location. And then if you click on that in GPS, it puts this cool looking thing. It's of no value, artistic maybe, but if you start to zoom in on a lake, one of the lakes we did, you see all of these place marks with labels. And if you click on any one of those place marks, it'll open up and tell you a whole lot about that. And again, this isn't very valuable either. But when you turn on and turn off the different place marks, it becomes more valuable. So here we have turned on the natural shoreline and green belts on this lake. And on this one, we turned everything else off and turned on the no green belts to show what areas have no green belt. We have detectable algal growth. Here we have, if you do it at a certain time of year, you can look for terrestrial invasives, TI. We happened to do this one in May where the yellow flag iris was blooming, and we could look for that invasive terrestrial. And then we'll take all of those data from the drone video footage, and it turns out to be extensive footage depending upon the size of your lake, and we put it into a table and of each of the categories that I explained, and then what percent of your lake is that. And then we think this is quite valuable, at least lakes around here have found it to be, where we can compare your lake to other lakes. And these are all lakes from the Northwest region of Michigan. And so if you were Lake 3 and you could say, well, how do we compare with Greenbelt? Oh, wow, we have 58. Oh, okay. Or is that good or bad? And so on. And we even took it a step further and said, well, let's make an algorithm that will give you a score. And so we put each one of these things, we valued them and put them into an algorithm and put out a score for your lake. We tried to make this all fairly positive, outstanding, working towards excellence, educating for change, and potential for great improvement. And I guess I would say that of all the things that we've done, all the studies that you do on freshwater, surface water, lakes, this one in particular for a lake association has promoted almost immediate action. A lot of studies are done and you end up with data and people read it, and it gets filed on the web page. But this one in particular, they look at it and like, wow, let's set some goals. And so to understand how this is done, you have to understand this is not a tool for individual lake owner analysis. So if you want to know how you're doing, this would not be the tool. For that, in Michigan, we recommend Michigan Shoreline Stewards. This is a general tool for how your whole lake is doing. So you're a team. Your lake, you all care about this body of water. And so if you have a lake biologist or you have a stewardship committee, it's sort of a grade on how are you doing in educating your people to do the right thing for their shoreline. That's really what it is. So we on Lime Lake did this a couple of years ago and presented the data to our membership at the annual meeting. And we as a board said we would like to increase our green belts by 3 green belts a year for 3 years. Now we're a pretty small lake, 140 properties. So we said, all right, let's try to do that. We presented that at the annual meeting, membership meeting. And after the meeting, we had 9 people come up. That day, 9 people came up and said, we'd like you to come to our shore and do a private consult to see how we could improve. and how maybe we could do a green belt. And so that was like almost immediate action, positive action. So we, that's really a positive thing. So that's a powerful tool for a lake association to use if they want to know. I'm going to pass this over to Dennis here in a second. We presented what we're presenting here at the Michigan Inland Lakes Conference. What Dennis is going to talk about with the drain field, and I could talk about the biology part of it, but he's going to talk about the drone part of it. That you can see this actually at the Michigan Inland Lakes Convention website. If you either take a picture of this slide or you'll have the PDF if you go on and look at that. You can go to that session and you could find or you could see this and see what's going on there. But Dennis, go ahead. What are we doing with drones here with our big 3-year enteric bacteria study?
Yeah. So this was kind of like a dream come true for me. Ron's daughter, who's working on her master's, was working on this project, 3-year project. And we had discussed before, Ron and I, and with Dr. Hannington, I guess, who's her advisor out of the University of Alberta, using thermal imaging to detect failing drain fields. And the idea here, and I read about this before, some tests were done, but nothing conclusive back in 2010-11. The idea is that drain fields, as they start to fail, retain more moisture. Moisture in ground retains heat. So you have this image you're looking at here was taken at midnight or 1 in the morning. So during the day in the summer, this area is being heated up by the sun. And then at night, the dry ground cools quicker than the moist ground. And what you're looking at midway through the picture horizontally is the drain field. And you'll notice the orange colors are the warmer colors. You can see the vehicle on the right, the paved driveway, that's all much warmer from the heat during the day. Down below, there's 2 little squares that, well, that's me with a pointer around it. And then the other areas were actually tree trunks. So what we have here is potentially retention of water in this drain field. And what was very interesting to see the differential in temperature, you notice what looks like a case of varicose veins in the middle of the picture. Those are actually, went back during the day to see what that was. And that was actually mole tunnels. So they're catching more air, they're cooler, and the area surrounding the drain field is cooler. So what we've learned here is we need to check this further. This was, and find out if in fact this field is at a stage where it's aging and retaining moisture. And if you think back to the image of the algae that Ron showed in the things that we're looking for, we did some research on that one, and it actually got some action that we didn't want at that time. But that algae, we checked elevation maps, and that algae was at a point where a rivulet comes through. There we go. And we checked all the elevations, and it led back several hundred feet to a community drain field. And then lo and behold, after this, that they saw this and they looked at it and figured it out, they changed the manifold in there. That turned out this distribution box was not sealed and potentially was leaking. But we have, there's a high probability that the nutrients were coming down there. We found other situations like that as well in this study, and before anything could be finalized, one drain field was replaced, and so it really was a call for action in a sense. But this is just another way the technology can be used.
Yeah, and the just 1 minute on the biology, we for 3 years on 90 different locations.
Right.
We took surface water every month and well water, and we look for using qPCR. We look for enteric bacteria, evidence of enteric bacteria, and that that manuscript is being written. I would guess sometime next year, there'll be a publication on all that. So if you're interested, it'd be something to look towards, and that we'll be evaluating all of these 90 drain fields to see if there's any correlation between what we found with the drone and what we found with the actual organisms that are there.
Yeah, so we may find this is worth pursuing and
Right.
going further into it. Here's an example. Actually, this is LiDAR from a satellite from 437 miles up. And as Rebecca was talking about, she had 10-foot intervals. These are half-foot. But we can also do this with LiDAR and with photogrammetry on drones. And the interesting part here, what you can learn. So if you look at the elevation of the lake is 618 feet. And this is a road coming through alongside a lake and properties on a lake. And you'll notice that the road is elevated. The driveways are elevated. There were quite lowlands, probably wetlands that were developed here. And then there's these small jelly bean looking things that are actually drain fields, mounded drain fields. And the interesting part is a number of them are within 4 feet or so of the elevation of the lake water, and the potential for exchange of nutrients here, pathogens and whatnot is really quite high. But it gives you some things to consider, to ponder, and think about whether the testing should be done. Ron, you probably know more about whatever testing was done in this area, but this will be.
Yeah, I would just add that in this township, this happens to be Lime Lake where I have a place, and our township requires that a drain field, the bottom of the drain field, it needs to be 4 feet above the surface or the water table. And so at 618, and this is the top, 622 and a half, 623, that's the top of the drain field. And these are mounded drain fields that maybe are 6 feet high. So we know that likely, and of course our data, our enteric bacteria data support some of this, that, you know, the water's going in there and going down and it's getting into the groundwater. And so there's some interesting things there that we know, at least in Michigan, we know that we need to pay attention to our septic systems and do a better job with that. So that's one thing we're working towards.
Well, certainly that's an issue in Minnesota as well.
Okay. Yeah. And mapping invasive species, again, the perspective of a drone, you can certainly see purple loosestrife here, but in this one doesn't show it very well. But on some places, you know, it's found back in where you wouldn't see it from a boat. And so we've found that doing it from a drone, it's just, wow, you get it really good. And it's like you say, all of it's archived, and we could fly the exact same flight, you know, again, and then if we're setting goals for getting rid of some of the terrestrial invasives. And another talk I'd like to, because I work closely here with the Lake Leelanau folks with their Eurasian water milfoil. Another talk, and it'll be in your PDF of this presentation, but you might want to look at that one to see what we're doing. So mapping, go ahead, Dennis. Mapping invasive. We shortened this and took all the videos out and made screenshots for you so it'd go quicker, but go ahead, Dennis.
Yeah, because this was about a 2-minute video, but what you're looking at here is north of Mosaic on Long Lake where I live. And we're looking at an infestation of Eurasian water milfoil. In 2020, I was awarded a patent for the aerial detection and mapping of aquatic species. And what we learned is we could locate these plants, and Ron will talk a little further because we're upping the game on this and the way we do identification and so on, the ground truthing. But what you have here is the ability to, we take these geo-rectified images. Again, we're using Google Earth because it's so easily accessible to everybody. And we put these things in, we can measure the extent, the area of these infestations, and we can make plans for permitting. On our lake, they choose to use chemical, but do the preparation. This also lends itself to another project that Ron will talk about here coming up. So very accurate. And the nice thing is now we've got drones and I've got RTK capability, which is real-time kinematics. I can put information within centimeter measurements. And it's really powerful what we can do with these orthomosaics.
Yeah, so a couple things. One is that if you were to see this as a video, he would come here and he would click over here and then over here and then around here. And then you'd look over here and you'd see how much square feet of that milfoil you have. And that helps you with if you're using chemicals for the applicator. The other thing is, why would you need RTK to where we could go back to a spot on the planet within a few centimeters? Why would you ever need that? Because some of the mapping we were doing on Lake Leelanau with the drone for Eurasian water milfoil, the drone was picking up individual strands of milfoil. And, you know, there might be 2 or 3 strands of the plant here, and that's it. That's all that's there. And we want to know where those are. We want to be able to go back to those. And it's just amazing technology with the real-time kinematics. So go ahead, Dennis.
So Dennis, this is Joe Shneider.
Yeah.
You used one term, which I've heard before, and I was hoping you might say a little bit more about it, which is ground truthing.
Yes.
Can you explain what that is?
Well, you're looking at these plants here, and on each lake, they have their own characteristic. They might have marl precipitation on them, so on. That makes the Eurasian water milfoil, which seems to be the biggest threat in our area, makes it look different, a little bit different from lake to lake. Also, the makeup of lakes, the diversity of plants, you may have other milfoils that are native that have some similar characteristics. So what we do, and you'll notice down at the bottom, there is my boat. When we're flying over this and we feel we have targeted what we need to do in that, we go and we direct ourselves right to it. You can see exactly where you are because the drone is flying and we're seeing on the boat exactly what's going on. And we can ground truth it. So we can do, and Ron will get into this, that's going to be very interesting what we've done to up the game on that. So I don't want to get too deep into it, but it's positively identifying what you're looking at. So that's what ground truthing is. Mm-hmm. Ron, this is what we see from high elevation. This was a video. I don't know how this one jumped in there, but this is when we're flying at about 200 feet. Yep. 270 feet, and we're looking for plants. And this one's not real sharp right now, but we had a lot of milfoil that they didn't know about, that long, narrow one coming down from the right and then across to the bottom left. In the upper area, midway up the left side, was an area that had been treated before and also had a lot of native pondweeds, mostly like Illinois pondweed. And because from the boat, they go back to the same spots and that, until we got up in the air and looked at this, they had no idea that this long, narrow band existed. And it was about 4 feet deeper. So again, the aerial view just opens up the plane incredibly. This here is an image of a treatment area. The boat with the sprayer is obviously the applicator. I'm on the boat lower right. Members of the association are watching on the left. And this is an image from a video that shows the application, and the captain of the boat, the driver, he has a 19-inch monitor. I'm giving him this view that you see, and he can go exactly to the spot that he needs to be and apply the chemical. What we have found is we have a greater efficacy in the treatment because we are putting the chemical right on the spot. He doesn't have the problems of looking through glare and so on that you have in a lot of cases, or even his own application getting in the way. So it really has up the game on that.
I can speak to this one. So we're working with Native Americans, a Grand Traverse Band of Ottawa and Chippewa Indians on Lake Leelanau, and they have a policy of no chemicals. And so we're battling the Eurasian with benthic barriers. It's well, not new in a sense. The magnitude that we're doing it at is new, where we're putting in burlap and leaving it in the lake. It degrades after 2 years. And I think the biggest one we did this summer was 40 feet wide or 30 feet wide. This one was 30 feet by.
Well, that one's 40, and you did 40 by 500.
Yeah, 40 by 500 feet long piece of burlap. So that's a big job, but well, actually, this part of it only takes an hour or so, but it certainly helped to have Dennis over here in the boat, and then on the boat here to have a monitor to show that, hey, we need to turn it a little bit if we're going to get it, because it's just tough when you're only 6 feet above the water standing on the boat. You just don't see. You want to see into the water. And the drone just goes up there and says, hey, okay, here's what it looks like. And it's really helped and will continue to help in our efforts on Lake Leelanau with the battling the Eurasian water milfoil. Then we're going to jump here, and I'm watching the clock here. We got about 15 minutes. So plant intercept method. What we did on North and South Lake Leelanau this summer, Dennis and I, is we said, could we up the game from what's called the point intercept method, which you lay a grid over top of a lake, and then you go to each one of those intercept points and sample throw the rake out and sample and see what kind of plants are there. We said, well, maybe we could up that. Maybe we could, that was invented over 20 years ago, that method. So what we did is step one is we use the drone to identify the plants. And so we thought, let's not go to places where there aren't any. Let's go only to places where they are. Let's intercept the plants and not the point. Second step then is we captured what's down there with underwater imaging, either with a scuba using a GoPro or GoPro on a pole. And the reason we chose that over the ROV is we wanted to come up with a method that doesn't cost a lot of money. In other words, you can buy GoPros fairly inexpensively, and versus say $5,000 for a ROV. And we wanted to be able to replicate it. In other words, go right back to that spot and look again and compare. And then step three is we conducted a rake toss along with that. We wanted to compare the two, and then the analysis and report. So let's talk about that. So we went up. This is a lake in our region that does not have Eurasian water milfoil, and it's right in the middle of lakes that do, but yet it doesn't. And we're definitely afraid of Eurasian water milfoil. So what we do every year is we go up with a drone, identify the weed beds, or we call them aquatic gardens. We identify those, and then we go back and we scuba dive on each one, because we want to do the early detection, rapid response. As soon as they're there, we want to get rid of it. We expect that we'll find it some year, and we want to not control it the rest of our life. We want to eradicate it. And so doing this method is what we're doing on several lakes in Northwest Michigan. We take a video, and again, I cut all these videos out, but when we go diving, and I'm the guy that does the diving, but I go diving, I take a GoPro, turn it on, and just scan. So we have a recording of what we saw down there in this entire aquatic garden. And these are little fish here. This is minnows that are right here. You can see that, but then you got some native milfoil. So that's one way we use it. But then another way is and I think I left the video on this one, is to go ahead. Yeah, I'm going to talk through this one. It takes a little bit, but so the drone is up and it's looking for a weed bed. We find a weed bed or aquatic garden, and we come under it with the boat, and this is what we did. And there's some cool things here, Dennis. This is showing the direction of the drone, the distance, showing the elevation of the drone, showing where you are on the lake, which is really, really good. And so we're saying, hey, here's aquatic gardens right here, right on the drop off. We can see that. Okay, so then we come in with the boat, and this is what we did on both North and South Lake Lino. These lakes, I think total is like 17 miles long. So a fairly, large lake. Come in with a boat, and what we did is we had 2 GoPros, one on an expandable paint pole, aluminum paint pole, one pointing straight down, the vertical view, and one pointing straight out, the horizontal view. And we would go, and Dennis is going to show this, he's going to come in with a drone here. And what we would do then is go to that spot in that aquatic garden, drop the camera, start the videos, drop the camera down, and you can see right here, if you look closely, that's me putting with the pole down and spinning it at least 360 degrees, and then bringing it slowly up so we have a good view of what's there. So we have 2 videos, and then we also wanted to compare that. Well, what is the rake going to show us? So we took the rake, the double-sided rake, and most of you probably know what that method is, and we chucked it over the aquatic garden and pulled it back to the boat. And then we took all of the plants that were there and put them on a whiteboard and took a picture. So we have video or picture evidence as well of what we found doing this method. We wanted to compare that all, and we did during this process. So anyway, this is a picture of the plants that we actually captured from the rake, and we tried to put them from most to least. And with a big monitor, we could blow this up, and we could, for most species, get it right down to the species level for most plants. This is actually, and again, I had videos of all these. I took them out because I knew we wouldn't have time. This is the vertical, this is the straight down view. And if you picture this camera going straight down, this GoPro, and it would go all the way to the bottom and then come back up. And here you can identify a number of different plants and macroalgae. The vertical or the horizontal view, again, taken at the same time on the same pole, is going on 360, looking at all the different plants as it slowly goes down. And again, you could stop each one, you could blow it up, you could look and identify the plants that way. So what we found, and the report has been written and submitted to Lake Leelanau, and I believe it's going to be available to anybody who would want to look at it. We found some advantages doing this method. Anybody can capture it. You don't have to, and then let the experts in plant identification analyze it. You don't have to know your plants. We purposely kept it at low cost, underwater video with using the GoPros. It is a permanent record. You can go right back to that spot and do it again. And I didn't mention this, or Dennis didn't, with the drone, but with the drone at a given height, we can actually tell you how big the aquatic gardens are. And with the autonomous flight that we're flying, he could go back next year, 2 years, 5 years, and run the exact same place with the exact same camera angle and get the exact same footage, and we could compare what's going on. We have an idea on how to actually make it even better by taking pictures of the leaf venation, which helps with especially the potamogetans, and simplify what we're doing. But we learned a lot, and the report will be accessible. I think the association will make that accessible, and you can contact us to see. Go ahead, Dennis. We got a couple minutes or a few minutes yet. Go ahead.
Yeah. So Glen Lake is a big believer in the drone technology. We have a great relationship with their watershed biologist. And on the upper left, this was a couple of years ago, I got a call from Rob, and he said, we've got an event happening. We had quite a rain event, and we have some concerned riparians. And that is flow from from Hatlam Creek that feeds their lake. And it was just a high volume of water, and it turns out to be tannins. See how it went to the drop off, but we get out there quickly. get the information. Rob gets it out to the membership quickly, puts their, calms their fears. And he's a great educator, explains them what happened, how it doesn't hurt, and so on. Bottom right was an interesting one. We had pink ice on a number of our lakes in this Northwest region. This is quite a ways from shore, but this was early April of this year. And we also, unfortunately, I don't have them show you, but along the shore where this, we had found this pink ice as well. So we were able to get imagery. Rob was able to get samples in that. I don't know what the outcome was. In fact, I don't know if they came to any real conclusion on it, but you can immediately document items, and we'll be watching for this again. And Ron, this is one you had on your lake.
Yeah, just on our lake this year, first time this happened, and this is about a 660 acre lake. This is a fairly large area that just had an algal bloom. It's not harmful algal bloom, but an algal bloom that we had never seen before. And I've lived on that lake for 22 years. So we took the drone and got record of it. And it turned out to be Spirogyra, which is okay, except that why did it just all of a sudden take off? And we'll be interested to see if next year that happens as well. Just a word here, and then I'm going to quickly shove it over to Dennis to share his screen. Feel free to contact either one of us. If we don't answer questions, we run out of time today. Feel free to do that. And let's see, I want to get rid of this. And
you're going to have to give me...
how do I go? Oh, here we go.
You're going to have to share screen.
Stop share. All right.
Okay, and then is that available to me now to share a screen?
Yep.
Okay. I'm going to show you just quickly. Ron was talking about what has come up in the last month or so. Can you see this overhead of the river?
No. Now I can. Yep, we can.
Okay. All right, so this is some footage on the North Branch of the Manistee. I got a call from, this came out of a meeting that Ron and I was involved with, Portage Lake. And they had the Little River Band of Ottawa Indians attending about fisheries. And they're on a project. In 1936, the Arctic grayling was declared extinct in Michigan. I think the only place you can find it now is places are in Montana and Alaska with any abundance. And they're looking at reintroducing to the rivers. They wanted to find out what the substrate is. So we went out and ran a test here. And this is what's really cool about the newer drones and with the zoom capabilities. And I will show you here. They're looking for substrate to see if it's suitable and areas that they can't get into. This is a beaver dam right here. But this is about 7 times zoom from about 125 feet, 115 feet. You go in and see get a pretty good idea of what is on the river bottom there. And we also, this is optical zoom. We also have a hybrid. It'll go into a little bit closer here in a second. And that's about 14 times. So it shows a lot of promise. Again, we can get right back to that spot very carefully, but they can cover we can cover about 2,500 feet of river within, really well within an hour or a little more. And that would take them actually a couple of days to do on foot. So we're looking to see if this will work for them. We just did this a few weeks back and it's showing a lot of promise, but we had now the Grand Traverse Band has called us, got a call from the Pine River Enhancement Association. And now the Leelanau Conservancy, they want to use the drones for monitoring their preserves, which is, I believe, is going to save them a lot of time. So we're going to go out and test that. So there's a lot of possibilities what you can do with this technology. It's limitless. Anyway, I'll cut that out now and give it back to you. There's some questions. There was one question here
There's a whole bunch of questions.
Yeah, the one in particular that Kevin Farnham had, and this is a great question. Won't the drone capability be limited by water clarity? And to a degree, but depending on what the function is, what you're doing, if you're looking for aquatic plants, keep in mind that with the clarity of the water also dictates how deep plants will grow. And we tested this on lakes in lower Michigan that don't have as good a clarity. And we were able to detect the invasive Eurasian water milfoil at depths that you wouldn't think you'd be able to see it. Another thing is, and I was working on a lake in Wisconsin, 2 lakes, North and South Twin Lakes near Eagle River. And they have some clarity issues there, but I'm able to gather the data at a flat level if needed, and then we can enhance it in post. I had a question for the gentleman there. I said, did you have some sort of apparatus that was treating the bottom? They had, yes, a distribution line that had ports, and you could actually, you couldn't see with your eye in the ambient light. You couldn't see more than 5 feet into the water, but down at 9 feet, you could actually see how this apparatus had killed the plants in a straight line. And otherwise you couldn't see it, but I was able to bring that out through use of Photoshop and capturing the data in a flat setting. But anyhow, that's a great question, but it does work very well.
We tested, we went to a mesotrophic lake this summer because we had the same question. We had the same question, and you know, we're working on some oligotrophic lakes, and we went to a mesotrophic lake, and we were really surprised at how well, for the reasons Dennis mentioned, that it does.
We found it in places they had no idea they had it.
Yeah.
And at depths they had no idea. Yeah.
Is it time for questions?
Yes.
It is.
Okay, I'm guessing a number of you have questions. I will tell you that the camera, as you can see, the folks that are still have their camera on are wrapped with this conversation. This is fascinating. Let me start off with a little one. Are there any privacy issues here? Is there any legislation you need that we should be working on with our legislators?
Not in our state anyway. One of the things, you know, that you have to understand is that the FAA regulates safety. And then the other question comes up is right to privacy, and that's regulated by state statute here in Michigan. The other question, kind of overlapping, is do you own the airspace over your property? And that's got 2 arguments. And the argument that I subscribe to is yes, you do. But according to the FAA, you give a easement to the public, and it's open. This easement is open to the public, and they have the right to pass over as long as they're not interfering with the enjoyment of your property. Okay. And so it is not a big issue to us. It has not been an issue. What we do find is when we're doing the shoreline surveys, which is one of the biggest things that we do, it has the most immediate impact for a lake, positive impact. We keep the boat ahead of where the drone is flying, and then we engage with anybody we come across. We let them know that it's happening, and 99.9% of the time you get a thumbs up because people are happy to see that the Lake Association is active on their behalf. In fact, you know, we've done shoreline surveys. We've done over 20 of these in the last couple of years, 4 years. And we have only had one property owner resist. And we have a conversation with them. I give my business card, I tell them who my contacts are. The one thing I remember is I am representing your organization. And what I know about the law and what I know about regulations does not matter. You want these people to be happy. I will not record that. There was one place on Portage Lake, that was it. I didn't record it. I let the association know, and they handle it on their own. It's not my place to get involved or create any further problems or potentially creating problems. And
the
it's worked out
and the
extremely well.
drone is over the water. It doesn't fly over their shore, it doesn't fly over
Yeah,
their
on the shoreline
island.
surveys, we're out maybe 50 feet or so.
Yeah.
So, but nonetheless, it's no different than going by with a video camera on a boat and recording the shoreline, except we're getting more information. Unless I have to be looking into their house, which generally is not an issue. But yeah. Any other?
I've got a million. So if anybody else has questions, go for it, because I could fill up the rest of the time.
Yeah, this is John Dennis. Wonderful presentation. I was just amazing amount of information. You've kind of progressed far beyond what I had even conceived could be possible. I had some questions in the chat area. One of the things I think we run into is that there is so much data, it's just hard to even look at it, to analyze it. I like your use of Google Maps. Have you put any of that, is that available for general use, is one. And the other question is, have you looked at using artificial intelligence as has been used for land-based plants? Have you used that for aquatic plant identification?
We have not used it, although I have some people that believe they can help us with that. I'm involved with a tech incubator here in Traverse City called 20 Fathoms. Unfortunately, I'm out in the field quite a bit, and I gave up my office there because I was spending money I didn't need to, but the collaborations were great. So that's not out of the question. But as Ron can attest, you still have to do ground truthing because there's so many plants that look similar. And, I don't know that you could get to that level that you need to be. I'm not saying it isn't possible, but I do have questions about that. Now, if you're looking for a particular plant, it may be good to narrow down, in that respect, rather than doing a complete macrophyte study of a lake. So if you're looking for like I say, a particular plant, it will narrow the field, so to speak. It possibly could do that, yeah.
So there's a number of questions in the chat.
Okay.
One that I think a number of us have is some perspective on costs for doing a shoreline survey. And I'll tell you the reason I would give that one a thumbs up is a few months back we had a presentation on natural shorelines, as you might imagine, and as a subcommittee of us was working together with the DNR, Minnesota DNR, we had a lot of conversations about can we get some perspectives as to how much natural shoreline there is in a given lake, or in a county, or in a whatever. And this seems to be able to be a very scientific way to be able to get that. So having some perspective of what kind of cost for shoreline surveys seems to be very, very relevant.
Yeah, so there's a gentleman in the attending, Jeff Johnston, Deer Lake. I think I have the right person. He inquired. I don't have the information right in front of me, But I did a preliminary estimate for Deer Lake, and I don't know if Jeffrey has that available or not, or if he's listening in. I see his name, but
Hi, Dennis.
few...
Can you hear me? I do have that.
Yes.
I will be bringing this to the board early spring here. And I haven't gotten back to you because I actually have a meeting on this tomorrow with our president of the association. So I do have that. Deer Lake is in Itasca County. We have about 20 miles of shoreline. And the preliminary from Dennis was, I think, just north of 10,000 for doing the shoreline survey. So hopefully that gives you the information.
Yeah.
Was that easy to understand, Jeff?
Very much so, yeah. And
okay.
Today's presentation was fantastic. What I also inquired about is seeing if we could get a copy of either the transcript video or the PowerPoints there. Because
Jeffrey, let me just give you a quick response to that. This is Joe Shneider. This section of the meeting on lake resiliency, this topic will be in a video that we will post to our Mincola YouTube channel as fast as we can get it out there.
Okay, great.
After the meeting. Yeah. So literally all of this that you heard and saw will be captured.
Great. Yeah, thank you so much.
If I might add to this, we like to first see a lake and understand it a little better, but obviously I wasn't going to drive 625 miles. And we've had some pretty good experience here now with what we've been doing, but we typically work on a miles of shoreline formula, a guideline. We want to make sure, that's why we like to visit a lake. And then Ron, with his analysis, has a algorithms he set up, because the shoreline characteristics are so different on lakes. You get a lot of canopy cover, and doing the analysis, making sure that he's in the right area. Your maps from the county equalization aren't always totally accurate. Like I said, we've upped the game with, we're now putting GPS coordinates that run live with the footage. So that'll make the analysis, the placement of the data points far more effective or more accurate. And so, yeah, there's some good things happening here, but we're really, it's a work in progress. It has been since 2017 when we started doing these. And that, so it's on the shoreline survey I'm talking about.
Yeah.
Yeah. You want to add anything, Ron?
Just that when Dennis started doing this, it all seemed like a great idea to the Lake Association. So he did a number of them. And they all said, well, we'll go ahead and we'll analyze it. Just give us the video and we'll analyze it. And so he did. He handed over on an external hard drive. Here's your all your video. And except for one lake, is the Rob Carner at Glen Lake, who's ahead of the game. Every one of them sat, and some of them sat for what, 4 years? From 27 to what's the latest one? Yeah.
2019. Portage
so
Lake.
They sat on the person who said, well, I'll do that in the wintertime. I'll do all that in the wintertime. And it never got done. And then to a person, I think our last one is actually, I'm on a meeting tomorrow with the township to see if, because we gave them a quote for analyzing it. But the point is this, if you know what you're doing, and we didn't, actually, I got to give credit to my daughter, who's a biologist, and we sit in younger, and said, hey, what would you do with this? How would you do this? And she came up with this whole analysis idea. And it does matter what your lake is like. If everybody just gets one thing, natural shoreline, move to the next one, natural shoreline, move to the next one. But if you go to one where there's beach sanding, no green belt, pipe, detectable algae, we've had some 5 place marks for each one. I'll tell you what, it takes you 5 times as long to analyze it, because you're going to enter that place mark, you're going to add all the information about it, and it just takes a long time. So we look at not only miles of shoreline, but we look at sort of the makeup of your shoreline to see how much work it's going to be for us to do that, the analysis part. So
Yeah, and the other sad part about things setting, and on one lake in particular that had Eurasian water milfoil and they didn't know about it, our high overfly that we do. So we do 2 elevations. We do one at, like I said, about 25 to 40 feet off the water. We do another one at 300 feet, and which will show you where your aquatic gardens are, any other issues like prop drags and so on the lake. But we had recorded the Eurasian water milfoil before anybody knew it was in the lake, and the person who I performed this for sat on it for 2 years. And in 2 years, it advanced significantly.
Yeah, not what you call rapid response.
No, it was not, exactly. And that's been learned. And yeah, so the fact that it sat, and there were good intentions on many of these lakes, good intentions to use this information, but life gets in the way. And, you put a committee together and, it's not their first thing, but when Ron's group does an analysis, that's their job.
Yeah.
And it gets it done. It's made these things far more valuable. Yep. Any other questions?
So you guys are doing this primarily in Michigan. You may fly over to Minnesota and do some.
It's possible. Yeah.
Is Minnesota DNR connected with you on this?
You mean Michigan?
No, Minnesota.
Connected with us? No.
Okay. And so
although
and my understanding is there are other groups that are other companies that are starting to do drone work in Minnesota, but you guys seem to have taken this pretty far. So that's very exciting.
Well, as Ron said, I was working on the lakes, or actually Rebecca said, since the late 90s when I got involved with our lake. And I just know how difficult it is to track an invasive plant. And I didn't know where I was going to go with using this with my background. I thought I was going to go in cinematography or whatever. I started I was going to do a video about the volunteers. Then I realized that I could find this stuff in the lakes, and I could adjust the camera to make it work properly, to see, you look at Google Earth, you don't see into the lake very well. So anyway, I got kind of a head start on it in 2015.
Yeah.
Yeah. And the problem back then was Part 107 that allowed you to operate commercially was not in effect. So you had to have a pilot's license to fly commercially, for manned aircraft. And I got my pilot's license in 2016. The rest prior to that was doing under the local college. And I was able to fly under their certification with their instructor. August 26th of 2016, I took my check ride, got my pilot's license. And on August 29th, they instituted Part 107. So I used that license for 3 days, invested $11,000 into it. But there was no development before that time in these areas because people couldn't fly the drones commercially, unless you were really a pilot interested. And they're, manned aircraft, they're not that terribly interested or focused on this.
So Rebecca, I see you're still on. if you do you have any wrap up comments you'd like to provide, or Jim Kutzner, or do you have any wrap up comments you want to provide? I mean, I could talk about this all day.
Well, let Rebecca jump in if she wants to. Well, anyway, yeah, I was the guy that was at the Michigan Inland Lakes Partnership Conference, and I heard this, and I'm an engineer, so I heard the word drone. Instantly, I was attracted to it. But then I realized I put your engineering stuff aside and figure out what are these guys actually accomplishing with it. And I started to realize, oh, this is great. Not only a cost cutting thing, it's actually a capability enhancement kind of thing. It can do things that we wouldn't normally do. Maybe we could do them. It was just too expensive or too difficult to get something done. So I think looking forward, I think there's going to be a balance between added cost and how much analysis, how much post analysis do you want to do? How much information do you want to glean from the data you collect? How useful is it? You have to draw a line someplace. I can see where you can be spending a lot of money doing that. But on the other hand, just having this capability available is I think going to be a great benefit for all of us.
Yeah.
So.
Well, one of the things is on shoreline surveys is the value of the historical data that becomes more and more valuable as time goes on. And you can go right back to it and look at it and see what's changed and make comparisons and that.
Yeah.
One lake wanted to know how many 2-stroke motors and how many 4-stroke motors they had on the boats that were on the lifts. So that was added. Because your video, you're just going, oh, that's a 4-stroke. Okay, there's a 2-stroke, and you can add things beyond the 11 things that we look at. There are other things you might be interested in that you could actually look for.
Yeah,
I think the data collection in the future is going to be tremendous because there's so many examples around the world. I mean, not just lake or water management, where longitudinal studies are suddenly available because somebody realizes, oh, we have all this data collected from here and we can slice it and dice it this way and come up with some new conclusions and all that. So I think preserving the data, you may not know how you're going to use it in the future, but somebody will find it useful.
okay, well, I think we got to switch gears here. From my perspective, this has been fascinating. I think it's eye-opening. I think it's going to lead us to ask a lot more questions. One of the things Jim Kutzner had suggested earlier this year was that maybe we need to have a much more comprehensive program around drones and what they can do for us. So we are kicking that around for next year's one of next year's focus areas, because this seems
Can we take a moment and ask the group here? I mean, would that be valuable?
Absolutely. I mean, we've got 37 people on the line here. Not all of them are necessarily paying attention, but I think most of them are, or they wouldn't still be here. I don't have a poll set up for this, but I think every one of you has the ability to give a reaction. At the bottom of your screen, there's a reaction button, and I think you could tell us whether or not you think having more content in 2023 about drones and what we can do with them would be, if you think that would be valuable, give us a thumbs up and we can kind of look around. Even if your camera's not on, we can tell you've given us a thumbs up. And I think we got lots of thumbs up. So, a brief response would suggest, yes, I think there's need for more, Jim. So we'll work on that.
Kind of an expected conclusion, but yeah.
Tom Watson, you got a hand raised?
Yeah, just a quick comment. Having experienced this last summer, starting Memorial Day with about 100-mile-an-hour storm that put trees through my roof, and in matters all summer long dealing with insurance companies and various other things. I have a son who has his pilot's license to fly these drones, and we use that to take pictures not only of the damage, which also included where's your boat lift on the lake and where is the section of dock that was blown, hundreds of feet away. So in other words, you can use it for insurance verification. But the other thing that was amazing in the course of that, remember in my PowerPoint this morning, I talked about second tier development in non-riparian lands. I had him fly over several sections of area. And what did we find? We found a guy with a bobcat taking out cattails and various other things, which is illegal, passed it on to the county as a matter of enforcement. This is the so-called carpenter issue. And so, we can be doing more things. And I think we should be looking at, in my observation from listening to all of this and having worked with this son, one, we got quite a few people out there flying drones around. The question is, what do we do with that information? How do we bring it into some place to be processed? In other words, is that the difference between Ron and Dennis? Or, do we have, people that can be trained to do what Dennis is doing in here, but we need some place, whether it's in Michigan or Wisconsin or Minnesota, to actually have that information handled in some ways. But I think that's all part of that future discussion.
Yeah.